Dear students, in this video I am going to explain the clipping circuit experiment. So diode is can be used as a rectifier which conducts current in one direction and does not conduct current in the other direction. So it can be used as a clipping element. So in this experiment we are going to verify a circuit which can clip off some part of the input waveform. So the input waveform given to the clipping circuit in this experiment is a 10 volts peak to peak voltage sine waveform. We can see plus 5 and minus 5 altogether 10 volts peak to peak waveform. It is given as input to the clipping circuit. So first we shall see the positive clipping circuit where the positive side of the input waveform is clipped off to some extent and negative sign is obtained as it is as output waveform, right? Negative part of the input waveform, it will be intact, positive part will be clipped off from this circuit, right? Now we shall connect the circuit first and give the input to the circuit which is a 10 volts peak to peak 1 kHz frequency sine waveform. Now we shall see what output we are going to get. So first we shall connect the input. Now take the breadboard. We have only two components here, right? Connect the resistor first. So just put into one hole and in another hole we put the resistor. Now take the diode. Now P side of the diode should be connected to the one terminal of the resistor. Now choose the P side, right, and connect in the same node. So you have got 5 holes here which are of same node. One is filled with one terminal of the diode, resistor. In remaining 4 holes you can put anywhere. So the same node you have connected and choose another node here, right? So this is similar to this circuit. Now we have to give input and we have to check the output. Input will be given between this resistor and this point. So between this point and this point we are going to connect the input and the output will be taken across the diode. So this is the output point, this is the higher potential point and this is the ground point of the output. First we shall generate a sine wave of 10 volts peak to peak and 1 kHz frequency using the function generator. Okay, so this is the function generator. First you have to choose, put a probe here and choose the frequency range first. You can choose the frequency range as H. You will have some kilohertz range also, but choose the frequency range in hertz only and adjust this, right? Adjust this using the to 1 kHz, around 1 kHz. Okay, so around 1 kHz you are having the frequency and now choose the amplitude. So the amplitude should be 10 volts peak to peak. Whether it is having 10 volts peak to peak, we shall see by displaying it on the CRO screen. So just display the waveform and adjust the amplitude to 10 volts peak to peak. So now you can see the waveform here. So I have chosen 2 volts per division, the option on this knob, and I have connected this waveform to the channel 1. Now this is occupying. See, using this knob you can adjust you can first choose the range here, millivolts or volts using these two, and then you can adjust the voltage here. So I am adjusting it on the CRO screen. So this knob is chosen at 2 volts per division. So if I adjust this waveform to occupy 5 main divisions, then I can have 5 main divisions peak to peak into 2 volts. So 10 volts peak to peak altogether. So I will make it to occupy. So adjusting the knob on the function generator, amplitude knob on the function generator, I am adjusting the waveform to occupy 1, 2, 3, 4, 5 main divisions here, 5 squares which are main divisions, each main division is 2 volts, so 5 into 2, 10 volts peak to peak sine wave with 1 kilohertz frequency is now generated and it is displayed on the CRO screen. Now we shall connect this input to the circuit, right? So this is the circuit. Let us connect this input. So we have already input is present here. So connect this one here and give this red one. This is higher potential terminal. So give it to the resistor here and lower potential terminal or the ground here, right? And give it to the black one. Now a 10 volts peak to peak and 1 kilohertz frequency input waveform is generated from the function generator and it is applied to the circuit and it is also displayed on the CRO screen. Now we shall see what is the output of the circuit. So on the channel 2 we are going to see. So just connect a probe to the channel 2 and connect it to the output of the circuit. So output one end of the or higher potential point of the output is this one. You can see I am connecting here. So in this column of 5 holes you can connect anywhere, which is a node here. Okay, now connected to the red. Now to the ground, so you can connect here itself for the ground connection. Now we shall observe it on the CRO. So after connecting the output, this is output is taken between these 2 points. So this is the higher potential point to the red and this is the lower potential or ground point. This is given to the ground. So in the corresponding channel you can see the clipped off waveform where the positive side of the input waveform is clipped off. Now you can choose the dual mode option on the CRO and you can verify both of them at a time. So first set it aside, choose the ground for the input, that is channel 1, and adjust the line of the input waveform which is on channel 1 to the middle line of the screen. Now put it in the AC. So you will get half cycle, that is 5 volts, half cycle, positive half cycle above the middle line, the reference line, and 5 volts, minus 5 volts, that is negative half cycle below the reference line. Now adjust it to coincide with this one. Now you can see the complete negative half cycle is obtained intact without any distortion or anything. So now the complete, not complete, some part will be retained. So this part of the positive half cycle is clipped off. Okay, so now you get the clipping circuit where this is the positive clipper, almost complete positive part is clipped off. A little will be there because of the diode cut in voltage. You are getting this one. Now you can measure the voltage where, right? So from the middle point or mid reference line, at how much voltage it is, you can measure. This is at 0.5 main division or 0.5 main division into 2, that is 1 volt. So at a 1 volt, up to 1 volt you are getting the waveform. After 1, that is almost 4 volts of the positive waveform is clipped off, right? So this is the positive clipper. You can just turn it into a negative clipper by just interchanging the terminals of the diode, you can get the negative clipper. Yeah, you can see there. So the negative part of the waveform is clipped off. Only you get the positive part. You can see positive part is obtained intact without any distortion and the negative part of the waveform is clipped off, right? So this is the negative clipper. Now we shall see the biased clipper. So just now we have seen this negative clipper, right? So in this negative clipper, entire positive part of the waveform is obtained, but the almost entire negative part of the waveform is clipped off. Now we shall see biased clipper, where some part of the negative part means some part of the negative half cycle is obtained, only some part is clipped off. So that means the clipped off part will be reduced now using biasing. So here you can see almost entire negative part is clipped off, negative half cycle. Now we will reduce the negative part which is clipped off using the biasing, means applying the bias. Now how to apply the bias? You take a voltage source and put it to the 2 volts. We are applying 2 volts. Now it is negative biased negative clipper. This is the circuit we are going to connect now. Negative biased negative clipper circuit, where here you can see entire negative half cycle is clipped off. Just now we have seen. Now here it is only some part of the negative half cycle is clipped off, and the remaining part will be obtained in the output waveform. So how much part it will be depending upon the bias you are giving. This is, we are applying a 2 volts bias, so this will be the how much part you are obtaining. It will be 2 plus V gamma, that much. V gamma is around 0.6 for diode, so up to 2 plus V gamma you will be obtaining in the output, and the remaining negative part will be clipped off. Now we shall see how we can connect. So already we have connected the resistor and the diode in this manner. Now connect the 2 volts supply. Now take a supply, adjust it to 2 volts using the multimeter, and you are having the variable knobs here to adjust the variable voltage. Adjust these knobs using multimeter. You can, right? I will show you how to check this one. Yeah, so I am adjusting this knob. You can see the voltage is varying here, and it is adjusted to 2 volts. So using multimeter, adjust the voltage to 2 volts of the source, and then connect these 2 volts to the circuit. So how to connect? To the P side of the diode, lower potential is connected. So take the lower potential point, this one, the black, and now you remove. Now the ground is different. Here in this circuit, ground is nothing but one terminal of the diode. Now between the terminal of the diode and the ground, we have to insert this bias, right? 2 volts bias. Between the one terminal of the diode and the ground point, you have to insert this bias. So what is this now? So between one terminal of diode, now to the negative terminal of the diode or N terminal of the diode, I am applying this negative potential, right? And positive potential is applied to, you choose another point here and apply it, right? Now the input is given between these terminals of resistor, right, this one, and now the other terminal of the input is this point now, that is positive or higher potential of the supply. So this is this point. Now the ground point is different now for this circuit. This is the ground point. So connect to the ground point. Now you can see the output. Okay, output is between this point and the ground point. This is the output point, output terminals. This is the higher potential of the output. This is the lower potential or ground potential terminal of the output. So between these 2 points, this is this point, and to the ground, right? This is the ground. Okay, between these 2 points, we are going to observe the output on the channel 2. Now you can see previously almost entire, now let me on this one. So almost entire negative half cycle was clipped off when there was no biasing applied. Now after applying the bias, some part of the negative half cycle is obtained as output and the remaining part is only clipped off. So how much part is kept intact in the output, we shall see. Okay, first we shall adjust this to equally, then adjust it. Okay, so how much part, just measure here. So from this reference line, right, from this reference line up to how much voltage we are obtaining this negative part. So this is one full division and around 0.2 and 0.3, between 0.2 and 3 we have this line, so we can have it like 0.3 main divisions. So one full main division and 0.3, so 1.3 main divisions into each main division is equal to 2 volts. So 1.3 into 2, that is 2.6. So what you have to obtain here actually, so you need to obtain how much voltage, you can see 2 plus V gamma. So V gamma is around 6, so 2 plus V gamma is 2.6, that is negative, minus 2.6 volts you need to obtain here. So this voltage, now we are getting minus 2.6 exactly here, and the remaining part is clipped off. If you remove this bias, the entire negative half cycle will be clipped off. By applying biasing, you can choose up to which voltage the negative part is clipped off. I am just adjusting the bias. You can see how you can change the part up to which it is clipped off. See, I am increasing the bias and decreasing the bias. Can you see? When I decrease the bias, you will get decreased, more negative part is clipped off. When I increase the bias, you are getting less part is clipped off. So using the bias, you can choose up to what voltage you can clip off the circuit. So this is the biased clipper. Similarly, you have positive biased negative clipper, and combinational clipper is also there. So you can connect the circuit accordingly and you can get the output. So this is about the clipping circuits. Thank you.